All right, let's look at number 6 on yesterday's worksheet. I already gave you the clue or the hint that if we let u be the inverse sine, then du happens to be the rest of the problem. And so that's u, the rest of it's du. And so you end up integrating just u du. So it turns into a relatively simple power rule problem. So up the power by 1, divide by the new power, plus c. So as with most of these, once you pick u correctly, the rest is pretty easy. This looks a little bit weird, I guess, the inverse sine squared, because you got exponents that look kind of funny, I guess. But nevertheless, there's our answer to number 6.
Yeah, that one's much easier once you got it.
Once you pick u correctly, life is good. Let's look at number 8 on this same worksheet. We said yesterday this kind of looks like an inverse tangent. I didn't write that down. A would be 3. And if this is u squared, then that means u is e to the 2x, which works out well to make the top be du, the 2 and 1/2 up there. So there's du. So we got 1/2 antiderivative of du over a squared plus u squared. But again, I don't know if I should have given you the hints or not, because they make the problem easy if you know what to pick for u and du. Because now this looks exactly like an inverse tangent problem. So 1/2 and then 1 over a inverse tangent u over a plus c. So we'll fill in the pieces here. 1/2, 1 over 3 inverse tangent of u over a plus c. And remember that inverse tangent has an extra a in it, so it's got an extra a in the answer. It's the one that has 1 over a out front. Sine does not have that 1 over a out front. And you could combine that to be 1/6, but safe stop, don't worry about it. Let's do number 9 just because it has limits on it, so that's a definite integral. There won't be any c's in there. And I guess we'll pick up some trig review as well, because we'll have to do, looks like inverse tangent of something. So this looks like inverse tangent if a is 1 and u is 2x, and du is 2 dx, so 2 and 1/2. Let's see. Oh, we have this u thing, so we could switch the limits. Did you guys switch the limits, or did you put x back in and leave the limits? Okay, so if I want to put x back in and use the x limits, that's completely okay. I haven't done that in a while, so I'll do it this way. I'll do it that way on this one. So let's see. This is now du over a squared plus u squared. And I'm going to kind of fudge things a little bit. I'm not going to write those limits down because they would not be right. They're not, this statement would technically be wrong if I put u and root 3 over 2. So I'm going to hold off and just kind of say, whoa, not yet. 1 over a inverse tangent of u over a from, and once again, I don't have u limits, so I'm not even going to put anything there. Let's see, a was 1, so that's nice. Inverse tangent of 2x. Now I've switched it back to x, so I can put my x limits back on there. So that's kind of technical, but it's important. If you switch to u, you're supposed to have u limits there. And if you know you're going to switch back, that's fine, but don't put anything there, and just switch them back to x limits when you get there. So 1/2 inverse tangent of root 3 minus inverse tangent of 0. And that is a safe stop because those are calculator-ready values. So, in theory, you know how to do pre-cal and trig and undo those, but if you're stuck, you can stop there. On a multiple choice test, it wouldn't stop there. Inverse tangent of root 3 is pi over 3. Inverse tangent of 0 is 0. So pi over 6 is our simplified answer. But given the option, there is nothing wrong with that safe stop free response answer.